Fernando, and welcome to everybody to the webinar on efficient domestic electronic appliances organized by the European Copper Institute. It's a pleasure for me to share the next half an hour, let's say 1 hour with you. I will go through this presentation, and as Fernando mentioned, we will have some time at the end of the session to answer for your questions. Today's webinar will cover the following items. We will learn how much energy typical electronic appliances consume, which of them have the highest share of household energy consumption, and we will have some views on how this is different through different geographical areas, etc. Then we will go to main eco-labeling legislation and trends, both looking at the European market in depth and then having some quick look to the US market, which is one of the relevant ones. Third, we will go through some energy-saving measures which are applicable to electronic appliances. And we will finish with some best practice examples, which can be helpful for all of us at our homes. Let's ask us a first question: what type of energy we consume in our households, in our homes? Well, historically, our first need has been to heat our homes. That has been for centuries. Actually, this comes from the time we used to live in caves. The first need, unless we were living in the tropical areas or in the Ecuador, all of us needed to have some heat in winter. So the first energy need we had was to heat our homes. And then the society has evolved, the economy is producing new devices which we all want to buy. We want to drink cold beer in our houses. We want to charge our iPhones at least once a day. So then we need more and more electricity. But as you can see in that chart, still the amount of electricity that we use inside the whole bunch of energy we use is still small. It still accounts for 1/4 out of total energy share. The second part of that chart gives us another view in terms of how much we pay. That 25% of energy consumption, which comes from electricity, costs us almost 50% of our total energy bill. It gives us a view on the higher prices of electricity, and also there is a very clear trend on a more inflationary item, the electricity, towards other energy uses. Out of the electricity share, we consume other things besides domestic appliances, which can be lighting, cooking, air conditioning, etc. But within all the electricity share, domestic appliances should account for almost 50% of electricity consumption. So we would have there are some figures from the U.S. Department of Energy that gives us a total amount of 13% share for households' energy costs. But which appliances really rank first? Before answering to that question, on that left-hand side of the slide, we just included a quick example so that it can give us a summary on how we calculate consumption. This is going back to basics, but I think it's really important. Energy consumption is the result of multiplying kilowatt times time of usage. This is really basic, but it is really important because sometimes it doesn't matter how big an appliance is and how much energy it consumes punctually, but it also is really important how many hours we are functioning with that device. In the example we have over there, we're comparing two appliances. One could be, for example, a clothes dryer, which has a power of 1,000 watts, and we use it every 5 days, and we use it for 1 hour then. On the other side, we have a 50 watt laptop that we use it very intensively because we work at home, and then we use it 8 hours a day. Which one consumes more? Okay, if we multiply kilowatts times time of usage, we would have that the laptop consumes 400 watt hours per day, and on the other side, the clothes dryer consumes 200 watt hours per day. So we always have to consider how much power a device has and how many hours we use it. On the right-hand side, you can have a chart where there is a classification according to the US Department on which of the devices consume more. Obviously, we find this clothes dryer. We find in the first positions refrigerators, freezers, washing machines, etc. Now, in terms of trends, there are some relevant trends happening in the last years. Usually, appliances related to electronics, also lighting appliances have been growing its share in the last years. This comparison we have here is a little bit old because it goes only until 2009. For example, in terms of lighting, I think things are changing. Now we're introducing LED technology in our houses, so I think it would be a trend in the next years that lighting, the weight of lighting consumption should go down. There are other uses which are also going down. For example, space heating. That is due to several factors, but main ones would be new houses usually have better isolation conditions, and also the equipment is usually better, boilers, etc. are usually more efficient. But the main trend we can find is that as we are having many more devices connected in our houses, we now have mobiles, computers, tablets, DVD players, etc., etc. Usually the consumption which comes from appliances is growing. Now we can see an interesting chart in this slide. We have a chart with the different European countries, and there we can see the electronic consumption per dwelling by end use. This is a picture from 2012, and sources and data. Well, we can see in this slide. We need to take into account an important thing. Europe has a little share of electricity for heating purposes. We still use, most of the countries use gas for heating houses or water heating. That's why, in terms of the usage of electricity, appliances have a very, usually they rank first in most of the countries, on top of other uses like lighting, cooking, or space heating. Actually, you can see that only in 3 countries, which are Finland, Estonia, and Czech Republic, there are the thermal appliances rank first in terms of electricity consumption, but in the rest of them, the electric appliances would be the first group of consumption. I think this is quite relevant. In terms of the mix at our homes in Europe, well, we have this picture which comes from IDAE, which is the Energy Efficiency Institute for Spain. And you can see which are the main appliances, which is its share in terms of energy consumption. You can see that the fridge and the refrigerator almost account for approximately 40% of energy consumption. I think this picture is good to see how things work in a Southern European country where you usually have less consumption in terms of heating because of better weather conditions. And for example, appliances that we've seen in the previous slides, like for example clothes dryers, don't appear because the penetration in Spanish households is very low. Okay, actually all this section was just an introduction on electronic appliances, and I would like to wrap it up with three basic ideas. First of them would be that electronic consumption is gaining share in households over other energy sources like gas. Electric appliances are also having a higher share as we tend to have more connected devices at home. And the third thing that I would like to summarize is that appliances energy consumption depends on three factors: the number of appliances we have per dwelling, its power, and the hours of use. Now let's move to the second point in the agenda today. In this section, we will have a look at the main trends in terms of eco-labeling. Well, basically, there are two main types of labeling that we're going to have a look at. One would be the mandatory labeling, and basically it is an eco-labeling which is introduced by force to some appliances by the regulator. And voluntary labeling, on the other side, it would be a voluntary standard which is usually agreed by the industry. It can be coordinated also by the regulator, and it usually represents ecological values of products. We're going to have a look at the main labeling solutions implemented in the European Union, and also we have a quick look at the ones in the United States. Now, well, let's start checking out how the European Union has evolved its regulatory framework on energy labeling. Well, it's 23 years ago already, in 1992, the 92/75 EC directive was passed, and it established one of the first energy consumption labeling schemes worldwide. This directive, I mean, very important because 23 years ago, well, there was little concern about these issues, but the European Union was already regulating this item. This directive introduced the scale that we all manage today. It's extremely well known for all of us and goes from A to G, being A, most energy efficient appliance, G, the least efficient. Within the years, this scale has evolved. New data has been introduced. New scale. Now we have the A+ or A++ levels to rank devices which are more efficient than the old A ones. But I think this was really a very important achievement to produce this scale and this first regulatory framework on energy labeling. Some years later, in 2010, actually June 2010, the 2010 2030 EU directive entered into force. And it introduced a set of innovations on energy labeling. Only to mention some of them, I would say, for example, for the first time there was a total uniformity in terms of labeling across the 28 EU member states. One very relevant thing also which made life easier for manufacturers and distributors, etc., is that the new label was absolutely language neutral. Every single text, apart from the data from the company, has been replaced by pictograms. These pictograms inform on many characteristics and many data on performance of the product, but no text is on it. And for example, one of the new things that has come in these new labels is that information on noise is included for many products. Each country from the European Union has established a timetable of energy label implementation according to the 2010-30 directive. We can see in this slide an example of UK timetable, which establishes deadlines for each domestic appliance, going from 2010 to 2015, depending on the complexity, how much mature the market was previously on labeling, and basically, setting up a strict timetable that basically has led that most products are by 2015, already use the new labeling specifications. Now, what's the purpose? What's in our view the real value of the real value that an energy label brings? I think it provides consumers, which the consumer is in most of the times is the weak part in an economic transaction. This labeling provides consumers with relevant information to compare appliances regarding energy performance. One relevant value, which has proven very productive, is that manufacturers tend to improve efficiency of its products in order to market them with better letters in the scale, going from C to B, going from B to A. So it is really useful for manufacturers in order to improve its products. Also, I think one of the good things of this eco-labeling is that many countries have promoted renovation programs on domestic appliances based on energy labels. Basically, most of you will know of some of them. Reno plans on fridges, washing machines, etc., where you get a discount if buying an efficient appliance, or by giving the inefficient model to the shop. I think one of the important values of the eco-labeling program in the European Union is that this is an alive program. What does it mean? That it can help it can contribute to reach more strict goals. If the European Commission now wants to go up to a target of 27% efficiency by 2030, eco-labeling can be a very good partner to achieve this goal, because you can always be more strict. In parallel with the technology improvements, eco-labeling can be more strict, so that it is a very good partner to reach those new goals. Well, and which are the results? What have we got? I mean, these programs we've mentioned are in force since early 90s, and we can start having some results. In the chart we have in this slide, you can see how we're doing with three main devices, which are refrigerators, washing machines, and televisions. For example, in the case of washing machines or refrigerators, energy consumption per household is really going down from the early 90s. For example, in the case of fridges, it has gone down from almost 300 kilowatt hours to around 100, and in the next years it can go down to around maybe 80 kilowatt hours, so the reduction is really considerable. And in other devices, for example TVs, we cannot see that well the energy reduction, but there are also other factors. TVs are not only TVs now, they almost computers, so there are other factors which can influence on its energy consumption. Just to show you the current energy labels, you can see it in the left-hand side of the slide. And well, as we mentioned before, one of the new things is that it is including those pictograms at the bottom of the label with very little or almost no text. And for example, you can see on the right-hand side of the label that symbol on noise performance of the device. Well, up to here we've seen mandatory labeling in the European Union. Just a quick example of a voluntary labeling, which is doing well in Europe, which is the EU eco-label. I mean, main differences is that, obviously, as we mentioned, this is voluntary. One other relevant difference is that this focus on life cycle analysis, not only consumption of the product when it is being used, but throughout the whole cycle, production, etc. This type of labeling, for example, is being used in other types of products like furniture, gardening, paper products, where you can really see that a product has a very reduced environmental impact throughout its life cycle. Well, and checking just quickly how our friends from the US are doing. In terms of mandatory labeling, in the US, the solution used is the Energy Guide label. You can see an example on the left-hand side of the slide. Main changes, I would say, from the European standard is that they make a much higher focus on operating costs of the device, as you can see in the middle of the label. Just let me show it to you. In here, there is a calculation on what's the operating cost of that device per year, and also one important difference is that they combine both the compulsory mandatory system, which is the Energy Guide, with the voluntary eco-labeling, which is Energy Star, and that Energy Star appears at the bottom of the label. The Energy Star, as we were mentioning, is a standard which is managed by the EPA, the Environmental Protection Agency of the United States, And basically, it's the United States symbol for energy efficiency. What Energy Star measures is that a product exceeds federal minimum standards for energy efficiency and quality. Okay. Just quickly, which products can earn the label? Usually, product categories must contribute significantly to energy savings. There is one important thing of this standard that it really measures that the product is delivering features demanded by consumers, and in addition with a better energy performance. Okay. I wouldn't mention much more about Energy Star, but it's quite common, and you will probably find it in many devices. Okay, and let's move forward. But we still have 10-15 minutes left to be on time. We're going to go through some energy-saving measures which can help us on reducing energy in the consumption of electric appliances at home. Basically, what we've done is order them in 4 solutions. One is something which is we've seen it in the previous section, which is first thing to be more efficient is to choose efficient domestic appliances when we buy them. Second, we're going to talk about standby consumption elimination. Third, we'll talk about monitoring solutions, and fourth, thermal appliances. Well, just a quick view on efficient domestic electronic appliances. How much do we save when we choose a certain type of appliance, let's say a refrigerator, a class A or A+, instead of a C or D? Well, and on that table, we've got figures on energy consumption of a refrigerator, but I would say there are plenty of calculators that we can use in order to compare appliances. I introduced over there the one which is popular at the European Union wide, but there are many others, and actually I'm going to give you a flavor on one example we've produced ourselves at Creara. We delivered a software tool for one of our customers, which is Endesa. Endesa has a website which is called Twinergy, where they talk about energy efficiency for all their customers and basically anyone who wants to know about energy efficiency. And basically, we produced a very simple tool which provides you a comparison between your current refrigerator and a new one that you're thinking of buying. Basically, you introduce 3 simple inputs, which are the brand of the model, the model, and how old it is. And you get basically, we find your current refrigerator. Usually you just have to click and say, yes, this is my current one. Then we provide you with an array of new models which have similar capacity to your current one, so that you can choose it. And finally, you get the result. In this example that we just made, in order to use it as an example on today's webinar, we can say that for a small fridge, we would be saving 29 euros a year, approximately 30 euros a year in energy consumption. If we think this fridge is going to be with us for, let's say, 10 or 15, 20 years, we would be saving between 300 or 600 euros in terms of energy consumption throughout its usage at our home. So I would really ask you to use these tools, because it really helps you know what we're talking about, how much money we can save by changing our fridge, changing our washing machine, etc. Okay, let's go with the example on standby. I mean, basically, we all know about standby losses. You've got the definition over there. It's the consumption that an appliance has when it's not performing. It's not switched off, but it's not performing, and it's just over there waiting for us to go and quickly reconnect it. Figures are talked by themselves in terms of household consumption. It should be around 10 to 12%. Let me show you a chart which will give us some light on why consumption from standbys is that much. Let me show you this chart. Here we have several domestic appliances. On the next column you have the power, an average power of these devices, and the power it has when at a standby mode. This would be how many hours we use it per day. For example, in the case of a television, we're assuming 3 hours per day. So how many hours are left for a standby use? I mean, considering that we have 8,760 hours a year, almost 9,000 hours, which is 24 times 365. For a television, there would be a remainder of 7,665 hours. So this multiplied by 12 gives us that we could save 16% of energy consumption on TVs by killing the standby. And this with all of them with a higher or smaller percentage. So basically, the three rules would be: if you're not frequently using a device, please unplug it. If you're going to shop a new device, check how much consumption it has on standby mode. And the third option, which is really interesting, is installing a power strip which has a scavenging option. Now I'm going to talk about these scavenging power strips of standby. Basically, what these strips do is that they measure the current that is flowing through the device when they're turned on. And when the strip detects that there is a decrease in consumption, then it cuts off the power, turning them off completely. And when you turn it on, the strip detects that there is a power demand and reconnects it. Usually you can save up to 50% of consumption from standby with this product. Well, in terms of monitoring solutions at home, well, there is a vast array of solutions nowadays, but I just wanted to give you a quick flavor of a solution which I think is practical, it's easy to use, it's quite affordable in terms of pricing, and it has several nice functionalities. You have the picture of this product here. This is called, it is usually called a smart socket. And basically, well, how it works, you have a software that you can use it on your mobile phone. You have the smart socket, and then you have a receiver which is at some point at your home, which is connected to the Wi-Fi network. Which are the functions that you would get with this? First of all, you can monitor electricity consumption. You can do really interesting things like check, for example, if your kids are turning on the TV when you're not at home. So you can monitor electricity consumption, but you can also monitor your wife, your husband, or your kids. Just kidding. You can obviously turn things on and off. You can program alerts. You can set timetables. For example, I want lights to turn on for the week that I'm going to be on holidays. I want to turn my lights on for I don't know, 1 hour a day, for example. And obviously this helps us to reduce or cut the standby consumption. But as I mentioned before, there are many monitoring solutions at home. I brought you just one example, and I think this could be a good introduction for you. Well, the thermal appliances, just to give you a quick flavor as well on it, basically several devices at home like washing machines or dishwashers have both usage of cold and hot water. Most of the times hot water is heated with resistors, electricity resistors, which have a high consumption. So if we have the thermal appliances that introduces hot water directly from the boiler, we are reducing the consumption of these electrical resistance, and consumption goes down pretty a lot. We can say, for example, almost 50% of electricity of a dishwasher. We're getting to the end of this webinar. Just in terms of best practices, I've included a couple of slides of two of the most relevant appliances we have at home: the refrigerator and the washing machine, and some recommendations or some best practices on how to operate them and reduce consumption. In terms of refrigerator, for example, temperatures should be between 3 degrees and 7, freezer temperature at approximately -18. We have approximately 5% more consumption for every single grade that we're increasing it. Not obstructing air vents inside the refrigerators, allow cooked food to cool before placing it in the refrigerator, cover liquids and wrapped foods, avoid opening the refrigerator if we don't need it, place it away from sunlight and somewhere where air can flow, or disconnect it if we are not using it for a long period of time. And in the case of washing machines, we can talk about, for example, at what temperature we should do the washing. The more hot water we use, the more the consumption is. Try to use them at full capacity, although new washing machines are much more efficient at low loads. Properly dosed detergent, etc. Well, I think this can give you a first look at best practices, and I wanted to give you some references on where we can find more information on many other appliances. And this would be it for today's for today's session. I think we managed to